Welcome to module 26 of database management systems. In this module and the next 4, that is for the whole of this week, we will talk about indexing and hashing. So, this is a quick recap of what we did in the last week, primarily talking about application development. And then specifically we focused on storage and file structure, that is how a database file can be stored, how it can be organized and in a manner so that we have efficient representation for that. Now, we will move on from there to and focus on the basic feature of a database system, which is the ability to find information in a very fast manner, the ability to update in a very fast manner, and we will see the reasons for which we do something on the database tables called indexing. And we will talk about ordered index in this module and about the index sequential access mechanism. So, introduction of the basic indexing concepts and the order indices, and we start with the basic concepts. So, consider a very simple example. Let us consider an example where there is a relation faculty which has name and phone number, and additionally, so just focus on the middle part, the pinkish part of the table, which is table faculty. Besides the two attributes, I have put a serial number for the records, which kind of can be considered as internal numbers of the database to identify each record. Now, let us assume that we have to search on name. Suppose we have a query that get me the phone number of Povitro Mitro. So, you can see that Povitro Mitro, the record name occurs at position 6. So, if we have to get the phone number, then naturally we have to look at all these entries from one end to the other till we come across Povitro Mitro, match the name Povitro Mitro, and we can access the phone number. Now, similarly, if we have to search for a phone number, we will have similar situation. So, if we want to get the phone number of the faculty having phone number 84772, again we will have to search on the phone number from one end to the other and find the name of the faculty. Now, certainly this will mean that if there are n records in the database, then we will need the order of about n by 2 comparisons to be done, or record accesses to be done before we can find the desired record, which is certainly not a very efficient way of doing things. And you know from your knowledge of basic algorithms that if we have a set of data and we want to find a particular one, then we can make it efficient by actually keeping the data in a sorted manner and doing some kind of a binary search. That is one possible mechanism through which you can do that. So, we can use that same concept now, and just look at the left side, the blue part of the blue part table, where what I have done, I have collected all the names of the faculty and I have sorted them in lexicographically increasing order, and with that I have kept the record number as a pointer. Now, since this is a sorted array, so here I can search for Povitro Mitro for the first query in a binary search. So, at least in the log n order of comparisons, I should be able to find Professor Povitro Mitro and get the fact that its record number is 6, navigate to the record number 6 in the table in the middle and take out the phone number. Similarly, without disturbing the actual faculty table, I can build a similar kind of supportive table on the right, the yellow one, where I collect all the phone numbers and have sorted on the phone numbers. I can again do binary search on the phone number 84772 and find the phone number, find the record number where this phone number occurs, and go and find the name of the faculty. So, you can see that naturally this gives us a alternate way of finding out, and certainly you would say that we could have kept the record sorted on name or on phone number, but certainly if we keep it sorted on name, the first query will get benefited, the second query will still take a linear time. if we keep it sorted by phone number, the first query will take a linear time. So, we cannot actually keep the data sorted on both, and therefore, this is just an alternate mechanism called the indexing mechanism, through which even though the original data is not sorted, by maintaining some auxiliary data, we can actually make our search mechanism more efficient, and that is the core idea of indexing. So, indexing mechanism is used to speed up accesses to desired data. So, as you have just seen, so what we search on is called the search key, and an index file consists of the index entries. As you have just seen, it has a search key and the pointer is the record number or the internal address of the record where it occurs. And certainly I have shown an example where there are just 2 attributes. In general, there will be a large number of attributes. So, the entry of every index would be much smaller than the corresponding record. So, the overall index file will be a much smaller one than the original, and we can index it. And there are 2 basic ways to index, and that is what we will discuss through these modules. One is called ordered index, where the search keys are stored in sorted order, as you have just seen, and the other is hash indices, where the search keys are distributed randomly across different buckets using concepts of hash function, which you must have studied as a part of your data structure course. Now, if we what should we index on? The basic question is, should we index on all attributes, should we index on one attribute, should we index on combination of attributes. So, so there are certain measures to decide as to what is a good way to index. So, that will be measured against the basic requirements of the database, that is, I should be able to index in a way so that the access time, the insertion time, the deletion time, all these should get as minimized as possible. And as you have just seen, indexing might mean maintaining additional structures. So, that overhead of space should also be minimal. So, with that with indexing, we should be able to do at least certain kind of accesses where a particular value matches the attribute of a record or falls within a range of values in a record. Those kind of searches, those kind of queries should become very efficient, and these metrics we will have to always keep in mind. So, let us look at the first concept of ordered index, which is pretty much like what we have just seen. So, in a sequentially ordered file, the index whose search key specifies the sequential order is known as the primary index. So, the sequential ordering is done based on that primary index. It is also called the clustering index, and please keep in mind that the search key of a primary index is usually the primary key, but not necessarily the primary key. It could be different from the primary key also. And if I create an index whose search key is different from the sequential order of the file, then we say it is a secondary index, and it is also called the non-clustering index. So, index sequential file is a ordered sequential file, which is ordered on the primary index. So, here I show an example, and this is the example of dense index file. So, you can see the blue part is the actual table, which has different fields, the ID, the name of the faculty, the department, and the salary. And this is as you can see that it is completely sorted on the ID in the increasing value of ID, and on the left the white is basically just the IDs, and with every ID we have a pointer, the record number possibly of the record that it corresponds to. Here all the indices that feature in the table are also put on the index file, and therefore, it is called a dense index. You should also note on the right that the records are interlinked through a chain, I mean kind of they are being formed in terms of a linked list whose purpose would be seen later on. Now, instead of doing ID, if I want to do a dense index on department name, then naturally the sequential file has to be indexed primarily on the department name. And as you can note that unlike the ID, which is also the primary key, and therefore, every ID value was unique, the department name is not a primary key. It is a different attribute which allows for multiple multiple records having the same attribute value, and therefore, when we sort, we have one instance of biology, but 3 of computer science, 2 of finance, and so on. So, when we make the index, we let the index collect all the distinct values of the department names, and for every department name we put a pointer, we put the index marking the first record in the sequential file with that department name. So, you can see that computer science points to the record starting with 10101, and then it goes on to the next 2 records. So, now you can understand why we need the linked list, because if we are looking for all those teachers, all those faculty who are associated with department computer science, then I can find it on the index file with the department name computer science, travel to the record, first record in that, which is of Srinivasan, and then keep going on this list through the linked list that we have on right, and find the record for Katz and record for Brandt, until we move to the next record for Kim, which does not match the department name anymore. Now, instead of dense index, we could also do sparse index. Sparse index means that instead of maintaining all the search key values that exist in the file, we just take a subset of that, and we maintain those in the index file. So, here again we are showing an index sequential structure with ID being the primary index, and we have chosen 3 of the IDs and kept them in the index file. So, in the sorted order. So, this if you want to say look at a record with search k value k, we can find the index record with the largest key value, largest search key value ID value which is less than k, and then search sequentially onwards, because these are all linked together in the sequential manner. So, naturally compared to the dense index, sparse index takes less space, and therefore, less overhead for maintenance. When we do insertion deletion, you must have already noted that if I have a dense index, then every time I insert a value, it will have to be the dense index file will also have to change. Changes will be required there for insertion as well as for deletion. For sparse index, it will not be required, because it will just be required when I am actually changing the record or creating a record which is existing on the sparse index. So, that way it is better than the dense index, but certainly in the dense index I can go to any record directly from indexing. In the sparse index, I need to first index and then go sequentially. So, it will be in general slower in terms of performance, and we will need to look at this trade off. Now, it is also, so these were the ways to do the primary indexing, where we decide the order in which we actually keep the records sorted, or the fields on which we do that and the index associated with it. But once since the data can be primarily indexed on one or couple of attributes, and that gets fixed, but we may want to search for other values also. To make that efficient, we create a secondary index. So, here we show an example where the primary index is ID. So, the whole all records are sorted in terms of that, and we are creating an index on the salary. So, that we can quickly find the salary of given the salary of an employee, we can quickly find the employee or the employees who get that salary. So, you can see that for secondary index, now it is quite possible that there are multiple entries for the same value of salary. For example, if you look at the salary 80,000, that is received by Professor Singh as well as Professor Kim. So, if you look at the index file of the index sequence of the salary values, you will find that against 80,000 we have 2 entries which mark to 2 different records corresponding to the faculty who are drawing that salary. So, secondary index naturally has to be dense and is created when we feel that there is a need to quickly search on that field or that set of fields, and we will discuss more about those issues later on. So, indices offer substantial benefits when searching for records, but updating index impose overhead, because if you create an index whenever you insert a record or a delete a record, or you change the value of a field which is indexed in a record, then certainly all these indices will have to be also updated, and therefore, while your access time significantly reduces because of indexing, your actual update insert delete update time will increase, and therefore, the indexing will have to be done carefully. So, sequential scan using primary index is efficient, but sequential scan using secondary index is expensive. So, you will have to bring them in blocks, and that will require couple of millisecond versus the amount of time that you need in the memory access. So, these are the factors that we will have to take into consideration, and we will talk more about those. Now, if I have a primary index, then naturally to be able to access the records, I will have to first access the primary index and then do a search in that, and then traverse the pointer to go to the actual record in the file. So, to access the primary record, we would prefer that if the primary index can actually fit into the memory, so that I can do a in memory search, like we do the binary search in an array. So, because if the primary index is large, then that also has to exist in the disk, and therefore, bringing the primary index into the memory and then searching will add to additional access cost of the disk, and you have already seen in the earlier modules as to how disk costs are expensive, disk accesses are expensive. So, primary index, if it is not in the memory, then we usually have a lot of disadvantage. So, to take care of that, if your primary index actually is large enough, so that it does not fit in memory, then we simply apply the notion of indexing once again on the primary index file itself. So, we construct a say on the primary index, we construct a sparse index. So, which is called the outer index, which is a sparse index of the primary index, and inner index is the actual primary index file. So, if now in turn the outer index, the sparse index of the primary index also is too large to fit in memory, then you need to do yet another level of indexing on it, and so on, till you come to a index list which fits into a memory, can be directly accessed. So, the cost for that. So, this is what is called the multi-level indexing, because you are following multiple levels for indexing, and the cost naturally of update, insert, delete increases, because now all of these multiple levels of indices will have to be updated when you do an update. So, this is what is a view of the multi-level index. You can see the outer index, which is sparsely indexed, and those lead to different blocks of primary index of the inner index, which is the primary index, and then you traverse to the specific block where your record is expected. So, with this you since your outer index is in memory, so you need to do one disk fetch for finding out the inner index block, which should be one disk page or disk block, one access, and then based on that to find another access to for the block in which the record exists. So, with this you would be able to manage with two block accesses in this case, and that is how the multiple. This would not have been possible if in this case you would not have done the sparse outer index, because you would have required the different parts of the inner index or the primary index to be fetched repeatedly from the disk till you could actually find the final result in that. So, updating the index, particularly if you do deletion, then if it is a dense index, then the deletion of the search key is similar to deletion of the actual record in the file, because it is dense. If it is sparse, then naturally you will have to take care of some of the cases, because if it falls within a range, then just deleting it would not matter, but if it falls on the boundary where it is actually sparsely indexed, then that will have to be appropriately updated. Similar thing will have to be taken care of in terms of insertion. So, first you will have to look up to find out where the record needs to be inserted, and then if it is a dense index, if the search key does not appear in the index, then you will have to insert it. In case of sparse index, you will have to do the additional care that whether it already belongs to the range, and or whether if it will have to be a new block has to be created, then it has to be also entered in terms of the sparse index. And if you have multi-level indexing, then insertion, deletion will be extensions of these basic algorithms. For secondary indices, frequently we want to find all records where certain value in a certain field which is not the search key or the primary index satisfies some condition, and we can have a secondary index with an index record for each of these search key values depending on what we expect, what we would think are likely fields on which more search will be done or more range queries will be done. So, to summarize, we have taken a brief look at the basic reasons for indexing database tables, which is to speed up the process of access, insert and delete, and we have seen that primarily indexing primarily focuses on speeding up the access process. So, in that maintenance of indexing, there is insertion and deletion might have some additional overhead, but since insertion and deletion both inherently needs access to be done, because you can insert only when you have tried to access and have found exactly where the record should occur, or for deletion obviously you need to first find the record to be able to delete it. So, even though it is focused, indexing is focused on improving the access time, it actually improves the time for access, insert, delete, all of that, but we will have to keep in mind that in the process there are certain overheads of index update for insert and delete that will have to be kept as a minimal, and the additional storage requirement will also have to be kept as a least overhead. So, with this we will close this module. We have taken the basic look at the index sequential access mechanism. This is called index sequential access mechanism associated with different database index files.